Good afternoon and welcome to Webinar Wednesday. Today we are joined by Justin Ross, Senior Technical Sales Engineer, and Elliot Weldon, Product Application Specialist at Fluke Biomedical. They will be discussing next level patient monitor testing, why it may be time to reevaluate your testing strategies. Webinar Wednesday would like to thank our sponsor, Fluke Biomedical. Fluke Biomedical is the premier global provider of healthcare test and measurement equipment, software and services. They serve biomedical engineers and quality assurance technicians. Reliability, accuracy and quality are the foundation of their company and products. Empowering you to focus only on protecting lives is their goal. So for more information, please visit flukebiomedical.com. Now, just a quick reminder about our Spring MD Expo. We're headed to the M Resort Spa Casino in Las Vegas from April the 7th to 9th. Join us for 3 days of education, networking, and the latest advances in medical technology products and services. Registration is now open, so for more details, please visit mdexposhow.com. Also, please mark your calendars for our HTM Mixer, which is being held at the Westin Indianapolis from May the 2nd to the 3rd. Our mixers are a slightly modified, smaller and less crowded event that still provides valuable continuing education, networking and vendor engagement opportunities. So again, more information and registration details, please visit htmmixer.com. I'd also like to tell you that TechNation magazine is excited to announce that we are taking applications for our 3rd annual 40 Under 40 powered by YP at MD. We are looking for HTM professionals who are under the age of 40 who have done amazing work for the biomedical industry, and applications are due by April the 26th. Please apply at onetechnation.com or see the flyer in the handout section of your dashboard. Okay, today's webinar is eligible for 1 credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. We'll be wrapping up today's presentation with a live Q&A, so please submit your questions anytime using the questions feature on the webinar dashboard. As I mentioned earlier, our presenters today are Justin Ross and Elliot Weldon. So Justin and Elliot, you may begin whenever you're ready.
All right, hello, I'm Justin Ross with Fluke Biomedical, and in today's webinar, oh, one more slide there, please, brother. Alrighty, in today's webinar, we're going to cover a few topics. We're going to do a quick review of PM procedure of monitor testing, why, when, and what you're testing, and then the benefits of automating your testing procedures. All right, so we have a few questions here for you. What factor most influences the reason you test patient monitors? There we go. It's my job and I will follow the PM schedule. I'm concerned about patient safety. I had an incident and I want to do more. I have inspection stickers and they need to be put someplace. So go ahead and select which one best suits your answers. And I'd like to tell you that we've not seen all 4 of these, but I think we have actually seen all 4 of these. Right, Elliot?
Now, can you see the results?
We can see the results, and perfect. Is it all closed, or should we wait for another second, Linda?
Nope, it's closed.
All right, it's closed. So we can see here. I'm glad to see that we do not have very many who said that I just have a roll of stickers. Yeah, but the top 2, it's my job and I follow the PM schedule. And then the second most frequent was I'm concerned about patient and staff safety. So those are great responses, and let's talk a little bit more about why we feel that these are the important 2, and the most important being we're concerned about patient safety. So let's start off with talking about some types of monitors. So you'll find in a hospital, not all monitors are the same. We have monitors that are ICU or CCU. You might find that these are the fully loaded ones that have every parameter under the sun in them. Bedside monitors. Now, these could be a derivative of the ICUs. It could be a similar model with a different base, but typically not as many parameters. Then there's spot check monitors, telemetry monitors, integrated ones. They're a part of a defibrillator or anesthesia machine, and standalone things like blood pressure cuffs or pulse oxes. So when we talk about monitor testing, we're talking about a really broad term. So it could be anywhere in the hospital, and it could be any one of these parameters. And with that, the different areas may have some different considerations we want to talk about. And we'll move to the next slide there.
So when we look at the patient monitor setup, there's a few things that we want to look at. The alarm limits, because in certain departments or floors of the hospital, we have different limits based on the patient need. Modalities, so on a lot of patient monitors, they have modules, and specific modules have certain patient testing, such as IBP, SpO2, and IBP. So certain floors have more modalities, and it's important to check you have the correct module for the location, because if that patient needs to be checked for certain tests, you need to have the right module to do that. A couple other things that are important are the IT networking settings. So for the central desk for the nurses to be able to monitor all the patients, you need to have the correct IT networking settings, meaning your subnet mask, your IP address, to let them know that, what the specific patient in the specific room, what sort of vital signs they have currently. And then with that, we have the accessories. So you want to make sure, even as a biomed, to make sure that after you've done service on equipment, that the correct accessories are in the room. I know that typically that might be the clinical side of the hospital's job, but seconds matter. And if you're already in the room, just double check, because you're probably going to know the accessories a little bit more than some of the patient staff. And those seconds count when it's needed.
I'd like to add some color to there, Elliot, if you don't mind. I go through a lot of different hospitals in the United States and help people with training, teaching them how to use their patient simulators and how to apply that to the monitors. And this is something that we do see a lot of, where they'll change out monitors on the floor, things will get changed out, or you have a patient who transfers to the hospital, the monitor gets carried with them, and it might not get put back into the same place. So in part of the PM sequences, it's really making sure that we do have these setups correct, and it does have the correct settings. I was at a facility here a few months ago, and we were troubleshooting through a few things and opened up the drawer to find an IBP cable, and the biomed's looking down and scratches his head and goes, listen, we haven't even had these monitors in months. Why is this cable still here? So we're going to talk about this a little bit more down the line when you're doing your PM procedures, but is that part of your procedure? Are we going through and making sure that we have the right accessories on the floor for that monitor? And does it have the right modalities? If you have a small or an infant or pediatric patient put in to an ICU, is that monitor capable of having the parameters changed to that child? So there's some additional considerations that may be getting lost in here, especially as we get more and more devices that we're responsible for. So
I was thinking about this too, Justin, that when I worked at the hospital as a biomed, sometimes the swapping of modules, or sorry, the monitor itself might have to be swapped out. So it's always important, especially if you're on a call and that work's being done at nighttime, to just again double check that you're using the right modules and accessories, because when you're on call, you're usually the only person there, and you definitely don't want to be called in again for something. You can double check when you're there on site.
100%, man, 100%. And actually, I'll even take that one step further. Another common thing I see happen is people have a set of test leads, because they know if they go find a good set of ECG leads and a good non-invasive blood pressure hose and a good all these and that and the other things, when they go out and doing the procedures, then they know that those are good working sets. So if they're going to find anything wrong, it's going to be with the monitor, not with the cables. But by doing that, we kind of remove that step of checking for leak tests. Like when you change out those hoses, if you're using the same test set every time, you might not find that the hose attached to that non-invasive blood pressure monitor may have a slight leak. A lot of them have built-in O-rings, that will start to get dry and leak over time and start to bleed down more and throw off your bleed down rates. So another consideration with that is are you using the accessories that are with that monitor? And I know a lot of people now are using a lot of disposables. Do we have the right disposables with it as well? So just some considerations as we're talking about this monitor setup. And with that, I think we have yet one more question.
Yep, so the question that we have here is your patient monitor cable an accessory or a serialized device? What this means is that there's certain manufacturers that have serialized their cables. So I guess what we're asking here is, are you using an accessory, meaning any cable that is attached to the device, not serialized, or do you have a serialized device, or are you not sure?
So we've seen this with a few of the new patient monitors out there where the computations are actually done in the cable and the monitor is just that. And some people didn't take that into consideration. Now all of a sudden we have to track and serialize each and every cable. So here we go. We have 75% saying that they're still accessories and 17% saying they're serialized and 8% saying they're not sure. And that is a completely legitimate answer this time, not being sure, because technology has been changing rapidly. I just got burnt by this myself here recently where I thought I had the most recent service manual to find out that that manual did update and I didn't have the most recent version of it. So same thing with these cables. The technology's changed. Are you up with the current technology? And Ellie, I think we lost your screen, big guy.
I just noticed that. Can you see it now?
Yep, we're back.
Okay, perfect.
But you might want to go into presentation mode.
I am in presentation mode. Does it look like it's in presentation mode?
No, it looks like it's in fix-it mode. All right, we'll give him 1 second, and I'll talk about the next slide as he's pulling up. Right now, all of our notes are pulling up at the bottom. Not a big deal. So let's talk about these different parameters while we work through this, because we're in a technology-based company, so go ahead, and that's when technology bites us. So let's talk about some of these common parameters you may or may not see on a patient monitor. We're all familiar with the ECG, but is it 3-lead, 5-lead, or 12-lead ECG? And just because your monitor has a 3-lead or 5-lead with it, is it capable of testing all 12 leads? Do we know if it's capable? Some of these examples might be like the patient monitor built into defibrillators. Some of them have an option for a 12-lead ECG. Some I've even seen or heard of that have more than 12 leads. SpO2, do we have the right SpO2 cable on it? Some are interchangeable, some are not. Is it, non-invasive blood pressure? Does your monitor have ascending non-invasive blood pressure or descending non-invasive blood pressure? Because this can change how you get your readings. And of course, we always know that when we're going to do non-invasive blood pressure, we should check that through a static pressure, not as a dynamic, because with that dynamic, we're going to have bleed down rates are going to affect it, the cuff's going to affect it, and what's the chances even at 60 beats a minute hitting at 120 mark right on the money. So we always want to do those checks at a static pressure and then just do verification it's reading right and check your alarm limits with a dynamic pressure. IBPs, how many channels of IBP does your monitor have? And does it have temperature, respirations, or pulse rates? Then we see some other parameters we might not be so familiar with. SpCO, SpMet, and SP hemoglobin. If you have the Massimo Rainbow technology out there, you might be familiar with these. You'll see this a lot in ICUs, or you'll see this on a lot of defibrillators, transport defibrillators, like the ones on ambulances and helicopters. That's a great technology. I'm a volunteer firefighter, and it's something we look at because we have a lot of people in and out of burning buildings or CO poisoning. So that's a great one. End-tidal CO2, BIS or bispectral index, cardiac outputs. Plus, there's so many new technologies that are coming out these days that we couldn't even think to list on this. Are you familiar with all of them? Do you have the capabilities of testing all of them? And what parameters do your monitors have on it? And with that, we go back to, again, if your monitor has it on it, just because the area it's in the hospital, it might not be used there, but there's a chance that module could get moved to another department. So are you testing that parameter anyways? Because there is a potential for that monitor to go from point A to point B.
So we have another poll question here. How was your preventative maintenance procedure built? And the options, we follow the OEM manual to a T, meaning that with the OEM service manual, there's maybe a checklist, and that's you're following the exact checklist. For response B, we use the OEM manual as a guide, but built in AEM. So you're using the OEM manual as like it says, a guide, but then you're editing and making changes so that you've built more of like a custom checklist, which is an alternative equipment maintenance checklist. C, we use the ECRI Institute guide. So ECRI posts specific guides on modalities for certain PMs. D, some veteran tech told me how to do it. And E, I don't know, I just follow the CMMS.
All righty. So it looks like we use the OEM manual as a guide, but built in AEM is the most prevalent, followed by we follow the OEM manual to a T. I want to talk about that one for 2 seconds. I hear this a lot. We go into a lot of facilities, you say they follow the OEM procedure to a T. But then when we start talking about it, we find out that there are some slight variances where it might call to use a certain cassette, or you might use to do it a very specific way. Well, we don't really do it like that. We do it slightly different. As soon as that happens, as soon as you make any of those variations, you're actually not following the OEM manual to a T, and you do have some sort of an AEM. But what's even more confusing about this, and Elliot, maybe you could talk to it a bit, is we've been into a lot of facilities where we'll have 2 technicians sitting at the same bench, working on the same monitor, doing it 2 different ways, especially when it gets to the electrical safety portion of it. Anything you want to?
Definitely, Justin. We've seen that quite a bit in shops that we've walked into where, also with that standards, have changed a little bit. So like Justin said, 2 technicians, they might even be doing close to the same test, but they're looking at different standards for passing and failing.
We had a pretty good example of this about a year and a half ago, where the procedure they pulled up and it was dated, said, oh yeah, here's the most recent procedure. And the technician said, oh yeah, but there was an amendment to that. Didn't you get the email? So if there are updates, another question you might have for your system is how is that update coming to me? Is it via an email? Are you the one making that update? Does somebody else make it and it's just in the system and you have to go find it? Is somebody actually going out and pulling these service manuals every so often and looking at them and saying, hey, this has changed over the years? That's happened a lot. A lot of these monitors have many revisions of the procedure. Some of them have had less testing required, some have had more. Some have had parameters in it change. And with that, have you adopted those changes into your shop, or have you evaluated to make sure that change follows your AEM or not?
Justin, I also wanted to mention that sometimes, in certain biomed shops, the procedure comes out maybe via email. And let's just say best case scenario, everybody sees it, they want to follow it. But then, if you've printed off an older PM checklist, there's a chance that you might still use that. And if there's a way to maybe control that electronically, that might be your best option so that everybody has to follow that, exact updated checklist.
That's a good point, Elliot. And another one we kind of hinted on there is local rules and regulations. It's quite possible, especially with these large hospital systems now, if your procedure is written in another state or another municipality, when it comes to NFPA, that's dictated by your local municipality. So if you're following NFPA testing for your electrical safety standards, and your municipality happens to adopt the 2008, but your procedure is written by a facility that's in 2012, you might find variances in there with electrical safety and what the test limits are and what parameters you need to be testing. And again, there's another variance here where we can discuss things. In the AEM, or in that OEM manual, in that OEM manual, it might list some sort of electrical safety testing. And another one we find in here is when it does that testing, in that manual, it might call out a standard like IEC 62353, but we're actually testing to NFPA 99 in our facility. So if that's the case, then once again, are we actually following that OEM manual, or do we accidentally flip ourselves into an AEM without even catching it? So the two takeaway points here: are we actually following that manual? And B, are we following the local guidelines that apply to our facility? Remember, different municipalities, different regions could have different electrical safety testing standards, which could dictate what we do and what we don't test on our monitors.
And also to this, why are we testing? So the medical equipment risk evaluation form is going to help the team and the administration team decide how often are we going to be doing these tests. And an example of that is here on the screen is the weighted score. And at the bottom, we assigned how often it needs to be done throughout the year.
I've seen variations of this form. We were talking about it the other day where people have taken this older form and changed it a little bit to their own adaptive needs, where instead of using it to determine how often we're going to PM it, I saw another version where they're using it to determine if they're going to leave the device on the PM schedule or move it to repair only schedule. Or they might use it to determine if they can follow an AEM with it, or if it has to be the OEM manual specific. So you might see different variations of this medical equipment risk evaluation form. And with that, when's the last time it was updated? If the manual has changed and you have an updated manual, is it going to change how this medical equipment risk evaluation form is scored and weighted?
So here we have when are we testing? So there's a few times when we're going to test medical equipment. An incoming inspection, which is going to be when you just receive new equipment. Preventative maintenance, which is based on the score that it's given. How often are we going to do tests on this device? And then post repair. Now, let's say you're taking apart the patient monitor and you make a quick repair. It's always important to test that device after the repair is completed. Let's say you're swapping out an NIBP motor. Because you've opened up that case, it's a good idea to check the other parameters also while you're doing your post-repair checks, because it's possible that maybe you bumped a cable or something was close to going out, and now that it has gone out. So make sure that you do a check after that. And then also with your incoming inspection, take a look to make sure that the electrical safety settings that you're going to be using aren't different, or a different standard for the incoming inspection itself, rather than when you do a preventative maintenance or post-repair check.
That's a really good point, Elliot. A lot of these monitors now, all the boards slide in together and the outside chassis holds them into place. And when you slide them out, it's possible for another board to become unset in it. Now you think and you hope that a lot of times that monitor will catch that there's an internal area like that. But again, it's our job to make sure that we don't have anything slip by and get out to the effective patient care area. All righty. So let's move on into concepts of lost information. So this is one of those things we like to talk about, and it's the fact that if we're following a CMMS, some of these CMMS systems have been handed down from year over year after year after year, and they've had these procedures in them modified multiple times, and people get complacent with it. It's very easy to remember, hey, I'm going to go out and I'm going to do this monitor, and I'm going to fly right through these procedures and possibly miss a step. Could it be a low important step? Maybe. Could it be a high important step? Maybe. But are we getting each and every one of those tests performed and making sure that they're done? Does your CMMS allow for you to capture that actual data and do anything with it? Can you do some trending with the data? Maybe you can start to look at the data if you are able to capture the actual results. Maybe you can start to look at it and see when all of a sudden your readings are starting to go up, or maybe readings are starting to go down. Here's another one, visual inspections. So I hear this in some facilities have moved their monitors into an inspection only, a visual inspection only style procedure. So we started talking about this more, and back in the day, when I was out there servicing monitors, if we had to do an electrical safety for it, we'd have to take all those cables off the monitor, and you had to unwind them, and you're running them through your fingers. And in that process, a lot of times we'd find nicks and cuts and cracks. Or if I had to take the monitor off the wall and flip it around to get to the ground, to the ground pin on the backside of it, connect my Kelvin cable, I had that monitor off and it was rolling it around in my hands, which would unveil some hidden things that I might not have seen just by walking the room and seeing it's there. So with these visual inspections, when we're rolling these back to visual inspection, are we actually really going in and doing all those things? So the argument I hear a lot of times is, well, the clinician will find this before we do. That may or may not be the case. Remember that clinician's responsibility is to focus on the patient care. They're watching the patient and how this monitor is reacting with the patient. So they might not see that you have a slightly frayed cable, or they might not understand when you get this weird waveform or this interference on the screen, what's causing it. So this is one of those places where I really do like to get ahead of it and be going through all those accessories and forcing myself to go through all these steps, because a lot of times, while I'm not maybe finding that specific thing I'm testing for, I'll find other things while I'm doing it. Cracks in the chassis, broken mounting bolts, bad cables, wrong cables, the wrong cable in the room. All those things really will are much more readily come into your fingertips by going through all those steps. Do you have anything else to add to that, Elliot? I think I got everything here, and I've kind of put some of the information too soon in the deck.
I think you did a great job of covering that. The CMMS line for trending of data, so we hear that quite a bit lately. Being able to track, history on devices, and tracking that the trend of maybe broken parts of the equipment, is something that a lot of customers, I feel like, have talked about lately. Not necessarily to us, but just in passing, since this is more of a CMMS tool, but just being able to track the data, so that maybe you can keep the uptime on the equipment a lot better.
Oh, thanks, Ben. You actually remind me of the point I wanted to make here. We see a lot of places also going to pass-fail testing only, where they're only going to annotate something that they see it fail. So you're losing a lot of this data. This data is no longer there readily available, because you're just recording a pass-fail statement on it. The argument is also made a lot of times that, listen, we have so many pieces of equipment to test. There's just no way that we can do all these tests anymore, because we have got to keep moving on and getting through all the things that are definitely broken and definitely having an issue. So those are some real challenges we face. So is there a way that we could start to collect data again and get real numbers so we can start to go back towards this trending, or while still getting it done in the time of, hey, let's move it towards visual inspection? Is there some sort of a middle ground? And with that, now, Elliot, does lead in what you're looking for our next slide.
So let's talk about the benefits of automation. So automation, again, is just doing what you were doing before, but let's make it easier, and save time, reduce errors, automate the workflow, and also have an integration from the testing itself, getting that information directly into the CMMS. So the benefits of automation are allowing for multiple parameter settings at once. So when you're doing your patient monitor testing, you might be testing multiple parameters: NIBP, SpO2, IBP. With automation, using a test tool, you can automate all those parameters at once. And one of the best parts about this is that when you're using your test tool, usually you have to press, I want to test NIBP, that's one test. IBP, that's another one. So there's a lot of button pushing on the device itself. With automation, you just run the test and pump up the NIBP on the monitor, and then you can take your measurements, put them directly into the work, or into the documenting the work. It allows for multiple procedure creation and assignment by control number. So what this means is that we can track the actual test by the control number, and also create the procedure and work orders, multiple of them at a time, allowing for time save, which redirects the tech focus from how to PM to what are the readings and what do they mean and are they correct. So with this, the automation is allowing us to not necessarily focus on the pressing the buttons on the device, but making sure on the test device, but making sure that the values are correct on the monitor.
Hey, can I jump in there for 1 second? I want
Sure.
to take these top 3 points and pull them together for some people so we can explain things a little bit better here. So creation of procedures. One of these things about automating systems is that we can create a procedure. And in that procedure, when you're creating this procedure, you'll be doing it like at a desktop, not when you're out on the floor doing your PM. So you'll have the manual in front of you and you can look in the manual. A lot of senior technicians who've been around the block, remember that question earlier before said, listen, how did you learn how to PM? Well, some senior technician told me how to do it. So that senior tech has been through it. Maybe they went through factory training. Maybe they were out on the floor and they've done it for 10 years. And they know they can still do everything in the manual, but if you take step 6 and step 3 and convert them, flip-flop them, now it moves more rapidly and more smoothly. You're still doing all the tests, but you're just changing the order in it. So by creating these procedures in a controlled environment where you can sit down with that senior level technician and go through, you might be able to build a procedure that's going to do all the same tests in the manual, but with less steps, because now you can check the baseline for ECG and SpO2 and NIBP and IBP, all of those baselines at one time, and then toggle control and then test all the high alarm limits and all the low alarm limits. Now his bullet point in about how you can create multiple procedures. You might have that same monitor, like I said, in 3 or 4 different locations in the hospital. But what you might find out is they have different alarm limits depending on where they're at in the hospital, or they have different auto detect of arrhythmias. So with this, you can have multiple procedures. So you can have a procedure for the monitors that are in the ICU and another procedure for the monitors that are in just the general care areas. And they'd have different alarm limits maybe. So that's one of these great things about automating this. Now, the next thing I want to point out to this is when we're talking about automating patient monitor testing, we're automating a simulator. So some of the things people notice is, well, hey, listen, when I'm automating my simulation, I still have to type my results back into the PC. That's right. So with an analyzer, Fluke sells 2 things. We sell analyzers and we sell simulators. With an analyzer, we're going to look at a medical device's output and we're going to record it and see what that output is, like a defibrillator or an ESU. But with a patient monitor, the patient monitor is what's monitoring a patient. So our simulator is sending out bio waveforms at a known value. And what you have to do as a technician is look at the screen of the monitor and see what that monitor's interpreted those waveforms as, and then type those results back into PC. But again, the time savings here is the ability to take those procedures and put them in a good order that makes sense and maybe streamlines it to fit your AEM, as well as do things like add pictures and PDFs so that your technicians can follow through how to do it. And then I'll hold my last comment for the end here, Elliot. Thank you.
The last, I just wanted to mention one other thing too. Earlier in the webinar, we talked about, technicians maybe doing older procedures or not following the most recent one. And with the automation, the last bullet point here is standardization. So using a tool, an automation tool, you can make sure that, the older procedures, leave them in the past and we can follow the updated procedure, just like Justin was talking about. So
hold on. I want to go back one more. I'm sorry, brother. I'm sorry. So that standardization you're just mentioning, with a workflow automation system, how does that update get to your technicians? And do you know that they actually have the most recent one? Is your system, when you automate, capable of doing those things? The other one point in here is, are we able to start to collect more of that data? When you automate things and you're plugging into a system, one of the things I always used to like to collect was my wall voltage. When I'm going to plug my monitor in, what's my wall voltage, especially when you dealt with isolated power supplies, to see if we're starting to get an unbalanced load. So that was always extra data I always liked to have as a technician as I was walking through problems in a facility, but I never had time to record. So is your automation system capable of recording additional bits of data that might help you as your job going out and finding out why there are issues in the facility? All right, man, sorry about that. Thank you.
No, you're good. That was great. We do have a patient monitor testing video on how to do patient monitors testing.
And in this video, we're going to use a system that Fluke Biomedical has called OneQA. This is our version of how we automate things. And we'll catch you back here after the video. In this video, we're going to show you how to do an alternative maintenance check and procedure on a GE-4000 patient monitor. Please note, this is not a standard PM procedure taken out of the manual. This is something we just built and made up to show you some of the highlights of the Fluke Biomedical system. All right, let's get into it here. So here we are in OneQA, and you'll see our asset list, and we'll go down to our patient monitor and click on it. And here you can see the picture of the Dash 4000, so we know we have the correct monitor. You also notice we have all the information, the asset tag ID, its location, the device type, manufacturer, model, the last time it was serviced, the next time it's due, as well as some special notes that I entered into here so I know exactly what I need to do to be able to perform this PM. I need a ProSumate and an ESA, which we have both on the desk. So let's go down and start the procedure. We'll click Run. And here we are. We have the date, starting time, and the tester. This is myself, and this is password protected, so this is like my electronic signature. This is the first place we're going to interact with our CMMS, where we have, we can either, this will automatically fill from the CMS, or we can enter it in. So we'll just enter in test 456. That's just made up number for today. We can see that we're doing a preventative maintenance type, and here's the asset information, the asset tag, the model, manufacturer, serial number. Moving down, let's start the visual inspection. So we can go through and follow the simple instructions and read them and select the appropriate answer. And you can notice that we don't just have pass and fail. We took things that like says if it fails, list below, list the failure below. Well, let's mark these all as pass. Oh, maybe this one is a fail. Let's see what happens. So if we fail something, we get a red X. So we either annotate this or correct a failure, in which case we can mark pass then. And we'll write down here in the box, no issues found. All right, moving on to the next step. We're going to do a non-invasive blood pressure calibration. We'll need all these devices. We're going to need a mandrel for our Fluke ProSumate, the connector or adapter hose, the blood pressure cuff, the patient hose, and the ProSumate. So I have all those on the desk. They're already connected. Here's some special instructions we pulled out of the manual. And now here's how to enter the service mode. So let's go ahead and do that. We'll follow the instructions here. We'll go to main menu and monitor setup, service mode, enter the code. And we are into service mode. All right, next step. We're going to need to set up our non-invasive blood pressure. Here's a picture exactly how to set up. So here's my hose to my adapter and to my patient circuit with the cuff wrapped around the mandrel. That's already set up and done. And here's the instructions. We'd read through the instructions. We're going to go over here to calibrate and NIBP and cal check. All right. Hold up there for a second. Here's a diagram showing us exactly the keystrokes. We pulled this out of the manual and embedded it, so we have no question about what we need to do. We're actually going to do two tests at once. We're going to do the non-invasive blood pressure leak test as well as the NIBP accuracy test. So let's go ahead and we're going to zero our pressure meter, which is built into the ProSumate. All right, it beeped. That's done. Now we're going to go ahead and hit start right here. Run test point, and we're going to start on our monitor. Now the monitor is going to go ahead and pump up, and we'll see the pressure build right here in OneQA. Remember, you never want to calibrate a monitor using a dynamic blood pressure. You want to use it as a static, solid pressure. So that's what we're doing here. This OneQA and ProSumate is also capable of doing leak checks, the pop-off valve check, as well as has a built-in pressure source. But the GE monitor doesn't need those things. It just needs to buy the manual just to do the cal check like this. So we pumped up to 250, and it's going to bleed down to 240. When it says 240 here, we're going to go ahead and push the stop button here. And if the pressure is within tolerance, which is plus or minus 1 millimeter mercury, we'll get a pass. If it's without that, we'll get a fail. So we're at 241. Wait till this goes to 240. It's bleeding down, a little bit more to bleed down here. There's at 240. So I'll push the button here. And my pressure was within 1 millimeter mercury. So 240 here, 239.8. Spot on. Now the next thing it wants us to do is wait after we reach to 240 and see if we're losing more than 1 millimeter mercury in 5 seconds. That pressure is holding pretty flat. So I'm going to say yes, we're losing less than 1 millimeter mercury in 5 seconds. Oh, which is a pass, which means this test is done and this test is done. So we have our green lights on the right. So now let's move down to the next step. The next step is we're going to do the vital signs and alarm testing. Here's our instructions. We're going to test the high and low limit alarms. And I put a special instruction in here because yesterday when I was setting up, I grabbed the wrong temperature cable and it had the 2 black rings. I need the one with 1 black ring. So I had the verbiage and I have a picture right here showing me to use this temperature probe adapter. And then I scroll down and here's exactly how I need to set this up. Here's my SpO2 to the finger probe. Here's that temperature cable I just showed you connected into the adapter, into the monitor. My ECG, my non-invasive blood pressure that we left in from the prior step. So that's good to go. Now watch this. I go down to the next step here and we're going to test all the high alarm limits with the exception of SpO2 because we can't have too high SpO2. So I just have it tripped for a low alarm. So here we go. We'll click in here. You'll notice once I hit start on OneQA, if you look at the Prosim 8, it now says it's in remote mode. So it is taking care of all the functions of the patient monitor at one time. I didn't have to do anything there. So we're good to go there. Let's go ahead and hit non-invasive blood pressure, and it's going to start doing that. So my heart rate's 160, so I'll put it in here, 160. All right, my ECG amplitude is displayed as 1 millivolt right there. Good. My waveform looks pretty good, so we'll mark yes. My respiration rate is supposed to be 40. We're reading at 40. It's right on the line, so we'll put 40 in there. The temperature is supposed to be 37.5. We're reading 37.6. SpO2 we have set at 90. We are reading 89. All right, now our blood pressures. This is just to verify that we can take a diastolic blood pressure. Since we're over pressure, it's going to take a little bit for it to catch it the first time. And you could hear it ran through once. It's running it through the second time. And there we have a capture of 275 over 190. So we'll put that into here. Systolic, 275. Diastolic, 190. And our map or our mean is 227. And we are shooting for a 255 over 195 with 215. So we're pretty close. It's the first time up, but we're not going for accuracy here. We're just making sure all these alarms are in fact sounding. As you can see by our rates, we're over all of them. Okay, so that's good. Now let's go to the next step, which is a normal vital signs rhythm. I click there, and you'll see instantaneously all of the parameters are dropping back within line. Now non-invasive blood pressure is still out, so let's run our non-invasive blood pressure again. All right, so all of our alarms are shut off. Our heart rate we have set at 60 and we're displaying 60, which is good because we only had a tolerance of 1. Our ECG amplitude is still ranging at 1 millivolt. The ECG waveform, there's a little bit of interference on there. I think we have a bad lead, so we can replace that for today. We'll call it good. Our respirations, that has a tolerance of 2, so we're reading at 20. It was set at 20, so we'll put that in here and see if we pass. That's a passing score. Our temperature is now at 32. Our SpO2 is reading 96, so we're only off by 1. Now let's look at our blood pressure again, as it's still adjusting itself down. All right, here we go. 129 over 82 with a mean of 101. So put that in here. 129 over 82 and 101. Now, if I was afraid this was a little bit too high, I could run it again, but this is just for demo purposes, so we're going to call it good. Now let's see if we can trip all those low alarms. So here we go. We're going to click in here, and it's going to change all the parameters on the ProSim 8. Notice I didn't touch anything on this ProSim 8, and everything has changed. So I didn't even have to know how to set this up. Everything changed automatically for me. My heart rate's dropping. My respirations are dropping, so we're getting an alarm. My SpO2 is dropping. Here we go. So we have a heart rate of 40, and over here it's reading 40. The amplitude is still reading 1 millivolt. The ECG waveform still looks pretty good. My respirations are 15. I should alarm here in a little bit here because our low is 5, so we're still above what our respiration rate should be. My SpO2 is at 73. It's the low alarms for at 90, so let's go ahead and we'll put my SpO2 in here. 73. My temperature is reading 30. Okay. And my blood pressure. All right, here we go. And our alarm, we're now at 56 over 27 with a mean of 36, which puts us out of tolerance. And the alarm went off, so let's go ahead and we'll set this at 56, 27, and 36. All right, we did all those parameters without having to touch the ProSim 8. So now we can roll right into our electrical safety test. So you'll see, silence that so we can hear better. In our electrical safety test, here's what we're going to do. We're going to follow an FP899, and here is the setup for it. So let me go ahead and we'll move my ECG leads. Up to my safety analyzer. All right. Now I'm going to leave this here for a second because I have to zero out my leads. So there's my setup. So I know exactly how to set up for my test, my ECG leads, and I'm going to take my red alligator clip back to here. But I know from running this a few times, I have to zero out my leads first. So let's go ahead and we'll move down to this electrical safety, and we're going to push run component here. Now it wants me to connect it to my null post, so I'll follow my instructions. We're already connected. We'll zero that out. Now we're going to connect this to that test point that we showed in the prior instructions. All right, and we're going to continue. And again, this might not be the way you do electrical safety. This is just an example. And you see it automatically generated a resistance. Push run on the next one. Continue. Again, I'm not pushing any buttons on electrical safety analyzer. I'm not adjusting anything. I'm simply hitting run and make sure it's powered on. All the results are automatically populated. We have passes there. We're going to move down to the next to the applied parts test. And here's how to set it up. Here's the diagram. And here's a picture. So we'll follow, make sure we have the picture set up. Yep, we're connected over there. And let's go ahead and we'll start this test. Look at this. All this data is automatically populated. So a lot of people make the argument about, well, we don't want to do electrical safety anymore. It takes too long. I'm not doing anything. The system is recording all these results for me already automatically. So why not? No special notes. And we'll put a PM sticker on it. That's our last green checkbox over here. At the bottom, we have a green light, which means the PM procedure has been completed. We'll click Done, and this is going to go ahead and save it over to our reports. From here, this is our results. We can make different forms of a report. We can do a modified report. We can do the all report, all the data. Here's our test. We just passed it. So we can modify these reports and what data you want to come over to your PC. So you see in this example, it has all the data included into this, but we can also get rid of a lot of these fields that you don't want to bring brought over, like the pictures and stuff, and simply import this back into your CMMS platform or attach it as a PDF.
Okay, thank you. We've got a few questions that have come in. So the first question is, can a cuff size affect NIBP reading on patient monitors?
Yes, the cuff size is very important to how big the patient's arm is. So there's different sizes of cuffs, and it's dictated by the arm's circumference. So it's very important to make sure that if you're in it's in a ward of the hospital for children, to make sure that it's a smaller a child's cuff, and then depending on if the patient's larger, they shouldn't be using a bigger cuff, and maybe a normal sized arm, just a normal cuff.
Okay, great. So why do NIBP readings on patient monitors vary from brand to brand?
I'll grab that one. So there's some few things to consider with it. Again, we have to make sure that we have a good hose and a good cuff. As cuffs get used, the Velcro is going to start to peel once you wrap around the arm, and it could give a erroneous reading because it's peeling that cuff open, not reading the heart rate, or you're going to have a leak. So the way blood pressure monitors work is it's going to pump up to a known value, usually 165 millimeters of mercury, and it's going to slowly bleed down. And as it's bleeding down, those rates are usually somewhere between 5 and 15 millimeters of mercury per second. So there's another reason. So certain monitors might bleed down at different rates, or they might be programmed to bleed down at different rates. So depending on how it's bleeding down and what the patient's heart rate is, so if you have 60 beats a minute, you have 1 beat every second. And if you're bleeding down 15 millimeters of mercury every second, it's a really hard chance of that catching it. So your blood pressure is 120 over 80. It's really hard to catch 120 dead on the money because every second you lose 15 millimeters of mercury. So it's somewhere usually between 133 and 105. But if your blood pressure monitor is bleeding down at a slower rate, you'll have a better chance of getting it closer. So you can see some variance there. So there are a bunch of factors that can change how these blood pressures are measured. And again, that's why when we're doing our blood pressure checks, we always want to calibrate to a static pressure. So 200 millimeters of mercury is 200 millimeters of mercury, and remove that bleed down rate from the equation.
Okay, great. A question actually has just come in. During check-in NIBP, do we need to use the cuff which was connected to the monitor, or can we use our own cuff for leak tests, calibration?
So if you're doing calibrations, you're supposed to have a calibrated source. It's usually somewhere between 300 and 500 milliliters. I found over time of trial and error that if I take an adult large cuff, a new cuff that I know is not leaking, and I stick it inside of my mandrels, my second mandrel down, that's right around 500 milliliter reservoir. So it's pretty accurate for doing those checks. So the incoming inspections, I like to use that known source, especially if your facility is using those disposable cuffs, because that's going to change every time with every patient. So make sure that your monitor itself is working, and then maybe find the rest when you're doing your rotations.
Perfect. Another question that's popped up is, why is it important to test alarms in a patient monitor?
It's important to test the test alarms in the patient monitor because, like in Justin's video, maybe the alarm for one area of the hospital for ECG is, for a high alarm, is 120. And then in another area of the hospital, it might be 130. Now, obviously, patient monitors do more testing than just ECG. So that could be for SpO2, IBP, any of the parameter testing that you're doing on the patient. And when a patient is in the hospital, sometimes they move around the hospital. So you as a biomed should just, when you are doing testing or repair, it's good to check to make sure that those alarms are set correctly for that floor or that area of the hospital, just to make sure that those alarms are alarming when they're supposed to.
Okay, great. I've actually had a couple of attendees ask this question. Is it possible to pull your test data into our CMMS?
Yep.
Oh, oh man, you beat me to it. 100%. Oh, go ahead, Elliot.
Okay. So yeah, it's definitely possible to do this, and with at least with OneQA. So we have an open API platform that allows you to integrate with different CMMS systems. And it's not just specific to CMMS, as it could be, field service management, asset management, and the way that it's designed can be, because of that open API, it can be sort of customized to the customer's liking. In addition to that, it wouldn't be just adding the test data into the CMMS. You could also be launching your test based on that work order or asset from your CMMS into, in this case, OneQA, which again, that also saves you time too. So it's getting your procedures ready for testing, but then also documenting within the CMMS. And like we mentioned earlier in the webinar, being able to analyze results is becoming more and more important, or requests from biomeds and field service teams. In pulling that test data directly in from the OneQA tool can allow you to do that.
Okay, got time to squeeze one more question in before we wrap up. Is why do you have to manually enter in the test results while using automation?
Well, I'll take that one. You might have seen us do that in the video when we're working with the simulator side of it. Remember, the patient simulator is sending out signals, but you saw something different when we got to electrical safety analyzer. So in the patient simulator sending out the signal, it's going to display something on a monitor, and you have to record those results back into the CMMS or into the OneQA. But with analyzers, when you got to electrical safety, we're analyzing the electrical output. So you notice in that, it automatically fill those results in for us. So there's a big consideration. You have to remember, if it's a patient simulator, that simulator is sending out the signal, and you have to interpret what's on the patient monitor screen. But in the case of an analyzer, like electrical safety analyzer, we're analyzing the electrical safety signal from that monitor, and we can automatically capture that and put it right back into the work order. That's a good question. We get asked that a lot.
Good. Okay. Well, we're coming up to our hour. So thank you, Justin and Elliot, for your time today and for such a great and informative presentation. I'd like to encourage everyone to visit today's sponsor to learn more about the services they provide for our industry. So please visit flukebiomedical.com. Just a quick reminder, you can obtain your CE certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1 CE credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. If you've missed any of our past webinars, including Fluke Biomedical webinars, please visit webinarwednesday.live to view our whole archive webinars. We will be back next week with another webinar, so please visit webinarwednesday.live for more details and complimentary registration. Thank you once again for your time today, and I hope you enjoy the rest of your day.